Okay, so we're up to chapter 7 of routing and switching essentials, and so of course we're going to look at access control lists. So we're going to explain how they operate, so how they filter traffic, the use of wildcard masks, and how you create and then place access control lists. And so then from there we're going to look at standard IPv4 ACLs. And so we'll look at how they can filter traffic, how you configure them, how you can edit them using sequence numbers, and also you can use them to secure VTY access. And so, of course, we need to learn how to troubleshoot ACLs as well. So we'll look at how a router processes the ACLs, and then we'll look at some scenarios for troubleshooting. So, operation. So what is an ACL? It's a series of iOS commands that control whether a router forwards or drops packets based on information found in the packet header. ACLs are not configured by default on a router, and so ACLs perform the following tasks. They limit network traffic to increase network performance. For example, video traffic could be blocked if it's not permitted. You can provide traffic flow control, so they can help verify routing updates are from a known source. And ACLs provide security for network access and can block a host or a network. They can filter traffic based on traffic types such as telnet traffic, and you can screen hosts to permit or deny access to network services such as FTP or HTTP or whatever it may be. So basically, we're mostly talking about the network and transport layers of the OSI model, and so and with standard access lists, we're actually only talking about the network layer. But in a later topic, we will actually look at more advanced access control lists as well. But anyway, so an access control list is a sequential list of permit or deny statements known as access control entries. ACEs are commonly known as ACL statements. When traffic passes through an interface configured with an ACL, the router compares the information within the packet against each access control entry in sequential order to determine if the packet matches one. This is referred to as packet filtering. And so basically, the first time it finds a match from the start of the list to the end, the first match it has, that is the one that will be actioned. And so it doesn't look at the best match, it just does the first match. And so basically with packet filtering, you can analyze incoming or outgoing packets, and that can be either at layer 3 or 4 or both. And the last statement on an ACL is an implicit deny. This is automatically inserted at the end of the ACL and blocks all traffic. So because of this, all ACLs should have at least one permit statement. So basically, if the packet being examined at the moment does not match any ACL entries, it will be dropped. And so, of course, if you have only deny statements, there is a default behavior, but you can't change the default behavior. The default behavior is drop unmatched. And so you've just got to be wary of that. Now, ACL operation. So ACLs do not act on packets that originate from the router itself. So they define a set of rules that give added control for packets that enter inbound interfaces, packets that relay through the router, and packets that exit outbound interfaces of the router. They can be configured to apply to inbound traffic and outbound traffic. Inbound ACLs, the incoming packets are processed before they are routed to the outbound interface. And the outbound ACLs, the packets are routed to the outbound interface and then they are processed through the outbound ACL. Now, wildcard masks. Now, basically, they are the inverse of a network mask. So, typically, of course, the wildcard masks do give you some flexibility, especially if you've designed your addressing scheme in a particular way. You can have a great deal of flexibility. But so basically, a wildcard mask is a string of 32 binary bits used by the router to determine which bits of the address to examine for a match. And so they're sometimes referred to as an inverse mask, since unlike a subnet mask where a binary 1 is a match, binary 0 is a match in a wildcard mask, and so that's what they call an inverse. Now, so here, let's just say we've got this address to be processed. We've got a wildcard mask of 00255.255, so of course in binary that converts to that. And so from that, basically the only bits of the address that need to match are the first two octets, 192.168. The last two do not need to match at all. They could be any value you like, but because we've got a 1 there, basically they're a don't care. While these must match, these we don't care what they are. And so basically, if you wish to eliminate all of the C-class private addressing range, this could be something you did. And so basically all of the 192.168s would match that, and you could possibly block them. Okay, some examples. And so here, if you supply a wildcard mask of all zeros, what you're really doing is you wish to match a host address. And so basically only that one address would be a match because all 32 bits need to match, and so of course it's a unique number. With this, it's the complete opposite. You can supply any sample that you like because all 32 bits are variable, so that basically means any IP address on the internet will match this statement. And so here we've got probably a more common way that you would do a wildcard mask is you've got 192.168.1.1, but the last octet does not matter, so it's a C-class address. You're just checking for the C-class address there. And so basically any host within that subnet will match it. Okay, so how do you calculate a wildcard mask? So basically, with example 1, you assume you want to permit access to all users from the 192.168.3.0 network with a subnet mask of 255.255.255.0. And so basically you subtract that from 32 bits of ones, and so the end result is 255, and so it will end up being 000.255, and so that would of course mean that the last octet can be any way you like. Now here we've just got a less tidy subnet, and so it's a /28 instead of a /24 that we had here, and so the mask is 255.255.240, and so basically we care about the first 3 octets completely, and then the first 4 bits of the 4th octet as well. And so it's just the last 4 that are set to 1, which of course equals 15. Here we've got a supernetted mask, and so we've got 255.255.254 or /23. And so to match that, basically, you've got the last 9 bits. And so the last bit of the 3rd octet and all 8 bits of the 4th octet. Sounded New Zealand. Okay, so now there are some shortcut words you can use which also explain themselves better. So if you wish to match a host address, of course you would normally supply the wildcard mask of 4 zeros, which is match all bits. So you can actually replace that wildcard mask with the word host. So instead of 192.168.10.10 quad 0, you could actually say host 192.168.10.10. And so, of course, that makes it a little more plain that, hey, we're just talking about one host address here. Now, when you want all packets to match, so this might be the last line that you might say, you know, permit any or permit everyone. So basically you've blocked all the traffic you want to block above, and then you say permit any afterwards. And so from there, you can use the word any instead of the full 2 lots of 4 octet numbers. And so again, that basically is a little more self-explanatory within the access list, saying, oh, okay, I'm permitting any. It does sort of make it a little more easily understood. And so examples of that are, instead of doing access list 1 permit quad 0 and then quad 255s, you can just do, say, permit any. And that, of course, is quicker to type, but it's also more easily understood by most of us humans. And so here, access list permit that host address, all 32 bits need to match. You can just say this host. And so, as I said, it does make it a lot easier to understand the access list when you're reading it like that, especially if someone else wrote it. Now, you can use access lists in firewall routers, positioning between your internal network and the internet. You can use ACLs on a router position between 2 parts of your network to control traffic entering or exiting a specific part of your internal network. So you might have a research and development department. You might block who can get in and out of that. You can configure ACLs on border routers, such as those situated at the edge of your network. This will provide a basic buffer from the outside network that is less controlled. And you can configure ACLs for each network protocol configured on the border router interfaces. Now, when it comes to ACLs, there's no carte blanche. Basically, you can have one ACL, this is down from the table there, one ACL per protocol, per direction, per interface. And so on one interface, you can have 2 ACLs for IPv4. So 1 inbound, 1 outbound. That's it. That's the most. You don't have to do it, but that's your maximum. So of course for IPv6, you can also have 2 ACLs, 1 inbound and 1 outbound. And so it's on a per interface basis. And this sort of implies per router, but it's actually per interface. Okay, some best practices. So before you start writing access control lists, your company should have a security policy. Now, hopefully most will do that. And of course, then you should base your ACLs on that security policy. And so basically this will ensure you implement organizational security guidelines. You can prepare a description of what you want your ACLs to do. So in other words, just have a plan. And then from there, probably best to use a text editor to create, edit and save ACLs. And so, you know, most of it will be reusable, at least partially. And so also it's a backup copy. And so you should not test your ACLs on a live network. You should have some kind of testing network that you can actually test them first. Or maybe if you do it out of hours on your production network, if you don't have the test network, but have a backup your original ACLs first. And so, yeah, don't cost your company money because you've stopped important things from working. Using ACLs requires significant attention to detail. Most mistakes can be very costly in terms of downtime, troubleshooting effort, and poor network performance. So you've got to be careful with it. It's all about blocking traffic. You've got to make sure you're not blocking the valid traffic. Okay, so creating ACLs. The proper place of an ACL can make the network operate more efficiently. For example, an ACL can be placed to reduce unnecessary traffic. So every ACL should be placed where it has the greatest impact on efficiency. Now, extended ACLs, which we actually aren't doing today, or in this course, need to be positioned as close as possible to the source of the traffic. Now, extended ACLs give you a lot more options of what you can test for. So you can test on both source and destination addresses, and source and destination ports or applications, and you can also to a degree get down to the status in the connection as well. So you can have established and or not established. So in other words, a clean new connection compared to an established connection. Standard ACLs are a bit more of a blunt tool, but of course a bit simpler to figure out. That's why you're doing them first. And you can only specify source traffic. And so because of that, you need to place standard ACLs as close as possible to the destination, because basically if you're just blocking a source range of addresses, if you put it right next to them, they're not going to be able to get anywhere. And so if you're trying to block a subnet from getting to this server, if you blocked it here, well, this subnet wouldn't be able to get anywhere. But if you block it on the exit interface here towards the server, well, then you'll only be blocking their access to that server. And so, yes, it's a lot more sensible. While extended, because you can be very specific about what kind of traffic you're talking about, you can block the traffic that's not required, but you can allow the other traffic through. And so because they're more granular, you can place them as close as possible to the source, and of course you can stop traffic that will eventually be blocked from having to go over your slower serial links. Okay, so standard ACL placement, as we said. So this example demonstrates the proper placement of an ACL that is configured to block traffic from the 10 subnet, which is here, to the 30 subnet, which is here. And so this is a filter. And so basically there are two possible places you can configure that access list on R3. You can have it on the serial interface inbound, but that will also block them from being able to get to subnet 31, which they might need to get to. But the best place, of course, is as close as possible to the destination, so it would be outbound on G00, and that will just block them from getting to that subnet. Okay, so how do we do this? So the command is called access list. So that's it here. Then you need to actually, well, with the numbered access list, you then need to supply a number. And so normally you would do from 1 to 99. If you've got more than 99 access lists, you can also use 1300 to 1999. But yeah, I haven't felt the need to use that, thankfully. Now, so it's access list and a number. And so basically, because you're actually making, with each command, you're making an access control entry. And so all of your access control entries that are in the same list need to have the same number. And so access list 1. And so then, of course, what are we going to do with this particular line? And so are we denying the traffic? Are we permitting the traffic? You can also put a comment into the ACL saying the following line will do this. And so a remark is just a comment. And so it doesn't actually get action, but it's there as documentation for your access list. So, of course, denial permit is, of course, what you will use normally, and then you supply a source address and then the wildcard mask, and that is it. And so, again, you've got the option of host or any, or you use the wildcard mask, and so as we were looking at earlier, and then from there, there is an option to do log, which basically means whenever this line is matched by a packet, it will actually log it to the console. And so that can be handy if you're testing something. You just in your testing environment, you might use that where you have it log, and then you test your traffic, and then you You just have to watch the console to see if it's matching or not. And so, yes, quite useful, but you wouldn't normally do it permanently, but yeah, certainly it's good for testing. Now, so an example here is access list 1. We're permitting this traffic, and so we're looking at 192.168.10.0. The first 3 octets need to match. The last octet does not, so we're looking at a 24-bit subnet here. So we're permitting that traffic. Now, how do we apply it? And so that's our access list. So we've got a permit statement, so that the traffic from this subnet will be permitted. Then we've got that implied deny any at the end. And so that is the only subnet's traffic that will get through this access list. So how do we apply it? So we actually go to the interface. So in this case, serial 000, and we do access group as opposed to access list. So it's because it's a group of statements. 1, so again, we're matching that. And out means, of course, it's outbound. And so when it's traffic leaving the router through serial 000, this is when this access list will apply. Okay, now, maybe there's a host that you wish to deny, but all the rest are allowed through. And so basically what they're saying is, well, first we'll kill the previous access list one we did, and then we'll create a new one. So that's what that does. That will get rid of not just an entry, that will get rid of the entire access list. And then you do access list 1, deny host that, and so host 1010 will be denied. But then you do, for the entire subnet, permitting. And then again, you apply it to an interface and away you roll. Now, basically, as you can see, you do a more specific command before you do an open command. And so if you had this line first, this host actually would have matched with that and that would have been allowed through. So you actually have to do the more specific wildcard mask first, the more selective, and then you do the open one later. And of course then we've got the deny any, and so again that's the only subnet that will be allowed through. So because this is outbound and S000 to the rest of the world, no one on subnet 11 is getting past that router basically. Well, they can go to that subnet, but they can't go out there. Okay, so another example, we're going to deny a specific host. And so here, we're going to deny host 192.168.10.10, permit any. And so basically, we've done much the same thing, but in the previous example, this host actually could talk to that subnet there, because it was only blocking it outbound there. And so there was nothing blocking the communication between the 2 gigabit interfaces. But here, that host can't get out of the network now. And it can talk to, can only talk within the subnet, but the rest of the hosts can go anywhere. Okay, now, what we were looking at previously were numbered access lists. Number 1 in this case, but of course a numbered nonetheless. You can actually have a named access list as well. And so the way that you do that is you do IP access list, not just access list, standard, no access, and so that's the name. And you'll notice that you actually change into standard named access control list config mode. So here, because you're in that mode, you don't actually need to specify what list it belongs to. You can then just do what it needs to be done. So deny host 1110, permit any, exit. And so that's it done. And so again, you need to apply that to an interface. So it's G00, no access out. And so what you're doing is you're blocking this host here, 1110, from getting into that subnet. Any other host can get into that subnet from anywhere, but that host can actually get out to the rest of the world, or any of these hosts can get to the rest of the world. because it's only outbound on the G00. Okay, so we did talk about using a text editor, and so basically you do access list 1, deny host, access list 1, permit. So this is the example similar to the examples we looked at earlier. Now, apparently that 99 is an error, and so what you can do is inside your text editor you can fix that. And what I often do is I'll actually put no access list 1 at the top of my text editor file, and so then fix or edit whatever's coming afterwards, and then I just paste that entire thing into global config mode, and it will fix it. And so it's a very handy way of doing things, and very quick. And as we said, you've got backups of it and the like. So there's lots of upsides to doing it in a text editor. Plus, copy and paste is a marvelous thing that you don't have an option of well, you don't have a very good option of with the command line. And so you've got to, if you're trying to change an entry, normally with numbered access lists, the only way to do it is to blow the list away and then create a new one. At least historically, that's the way it's been. Now, that you can actually edit these things. And so, again, if you've done this and made an error, so it's the wrong host number, if you do show access lists, you can just do show access lists and it will show you all of the access lists, but if you just do one, and you'll see that it's actually got numbers, sequence numbers on it, and so they're a space of 10. So if you wanted to add a line in between them, you could actually just go 15 and then whatever you need to do, and it would actually put it in between. Now what you can do with this, and so this is actually using the named access list version, is you can actually do no 10, and then you can do a new 10, so deny host that, and it will actually end up being the way it should be. So so that is a way you can do it in the command line, but I still find the text editor easier. And so editing standard named ACLs is exactly the same process. So again, as I said, if you wish to add another deny host line in there, you can just, so you do the show access list, you can see that there's lines 10 and 20. I would need to put a line in before that permit statement. And so you just go in and edit it with number 15, deny host and the new entry, and then end and done. When you look at it, there's 10, 15 and 20. If you reboot it, if you of course did a copy run start, and if you rebooted it, it would actually end up being 10, 20, 30. It's only sort of valid while it's there. So that's why they do the 10 spacing. So how do you verify ACLs? If you do show interface, it will actually show you that there's an access list and what direction it's in. You can show access lists is what I use pretty regularly. And if these access lists have actually been active, it will actually give you a count beside them, how many matches each of the lines have had, which is very, very interesting as well. And so actually, how we said there's an implied deny any statement, I actually myself put in the deny any statement at the end, just so that I can get that count, because there's no line there for the count for that to happen. If I put that line in myself, it won't change the way it's processed at all, but it actually gives you the count of how many times that deny any statement has been used, which is certainly of some use as well. So as I said, this is how you get your count. So you've had 8 matches there and 4 matches there. If you do clear access list counters 1, it'll actually clear those counters. And so if you've edited it again, you want to clear it and see what traffic's doing now, you can do that quite easily. So this is actually reiterating what I said the previous slide. Because there's the implied deny any statement, if you put that in yourself, you'll get that count, which I said is very handy. Okay, now access class. I think this is pretty much getting towards the end of what we're doing today. So we've all done VTY access. And so what we can do is we can actually control exactly which hosts can do VTY access. And so we have line VTY04, login local. And so we're using a local database, transport input SSH, so only SSH is permitted. Access class 21 inbound. Now, this is where actually a standard access list is as good as an extended one, because we already know what the destination is. Because if it's gone to this VTY, we know that someone wants to SSH into this router, and so we actually don't need an extended list for this. And so here we're basically allowing anyone from subnet 10 to be able to telnet in, no one else will get in. And so that's a very quick and easy way of controlling who it is. Of course, you could do host 10.10 again, so that's the only host that's allowed to. That might be your network admin's computer's address, and so a very, very cool way of controlling who can telnet into your telnet, or SSH in this case, into your router. Very good idea. Okay, so of course we're using access list 1, and so we've had 2 matches to that, and we've had 1 match to the deny. And so we've who's allowed in? 10.0. Yeah, so this one worked, of course, and this one was refused. Okay, so how do we troubleshoot? So, so a single entry ACL with only one deny entry has the effect of denying all traffic. A quicker way would just be to unplug the cable. Same end result. At least one permit access control entry must be configured in an ACL, or all traffic will be blocked. So study the 2 ACLs in the figure on the left. Will the results be the same or different? So we've got permit IP. 192.168.10.0, so that's for the subnet there. Permit IP, well, there won't be any difference because we've got a deny any, but there's an implied deny any there anyway. So the only difference is that you'll actually get a count on this one if you do show access lists. Okay, and so as I've said before, the order of access control entries is important, because as soon as you have your first match, that will stop processing of that access control list, and we'll just do whatever it is, deny or permit. So the access, and so here we've actually got one that has a subnet being denied, but a host being permitted. Now iOS actually does apply some sort of logical analysis to your commands, and it's noticed that, hey, you've configured at a higher sequence number is a part of an existing rule in number 10. And so basically what they're saying is this one will never match because this one will always match. And so it does sort of try and vet what you've done. And so because it does match part of this range, 1/256th of the range, it does actually sort of look at it and go, oh, you've been actually more tight with that one than that one. You should have it in the opposite direction. And so, yeah, it does do some checking, but of course it's a computer. It's not incredibly perfect at that. And so here we've got some network statements, then we've got host statements. And so the range domain statements are displayed in the order they are entered. The hashing function is applied to host statements. So basically we'll reorder it just because they're host. So how are they processed in a router? So a frame arrives on a router interface. So is this addressed to me? So layer 2 address, yes, cool, I'll carry on. If it's not, I don't care about it. So are there ACLs in the interface? No, well, we'll just forward it. If there are, okay. Then so basically we'll go through each statement until you've got a match. If there is no match, we're going to bin it. If there is a match, we'll do whatever that match says. So it's going to be permit or deny. And so then it will actually then be routed. Okay, so troubleshooting example. So the most common errors in ACLs is entering the ACEs in the wrong order, not having specifying adequate ACL rules, or applying the ACL using the wrong direction. So the figure to the left, the PC2 should not be able to access the file server. However, PC1 cannot access it either. So we've included too many. So the output of the show access list command shows one deny statement in the ACL. The set of commands on the right shows the solution. So the permit statement allows other devices to access, since the implicit deny was blocking other traffic. And so again, we've broken the rule in that we've only got a deny statement in ACL, so that was blocking everyone. And so you just needed to add another line in there. Access list 10, permit any. As long as you're trying to block just one host, that's good. All right, so another example, we've got the subnet 192.168.11.0 should not be able to access the subnet 10.0. PC2 can not access PC1 through router 2. So the problem is the access list 20 was applied in the inbound direction. And so we've got this. Where's the access list? So we've got access group 20 inbound. And so it doesn't actually show me the access list here somewhere, does it? Anyway, so of course it's basically in the wrong direction. In this example, we've got only PC1 should be allowed to SSH into R1. There is a problem with the config in the figure to the left, since PC1 is unable to SSH into R1. So the ACL is permitting 192.168.10.1 address, which is the interface on G1. However, the address that should have been permitted is 10.10. And so basically we're permitting that, but of course that's itself. It should have. So as soon as you fix it to 10.10, it should work. A little bit trivial, but anyway. So that is access control list, and so we have come across a few new terms in this. So access control list, firewalls, access control entries, which are of course the individual lines, packet filtering, standard ACLs, extended ACLs, implicit deny, inbound ACLs, outbound ACLs, wildcard masks, named ACLs, and inverse masks. Now, of course, you being able to do some security is certainly a good plan as well, but also ACLs are not used just for controlling traffic. They are also used to define a range of addresses. And so in one of our later chapters called NAT, Network Address Translation, we actually use an access control list to define what are valid addresses that we wish to translate. And so they're not just used for controlling traffic, they're also used for just defining a range of traffic as well, because the addresses plus the wildcard mask do that nicely. And so we will be using ACLs when we do NAT in the coming chapter. All right, that's it for chapter 7 for today. Have a nice week, and I'll see you later.